Assalamu alaikum. In this video, we want to continue Chapter 13, Hooke's Law. Objectives. At the end of this video, students will be able to state Hooke's Law, recognize that the curve obtained by tracing t as a function of x is a straight line passing through the origin. Read or plot the curve of elongation of a spring. If you remember, we learned from the previous lesson that the force as a definition is a mechanical action exerted by a body on another body. When this body exerts a force on the second body, then the second body exerts a force on the first body, where this is called principle of interaction. And on the same body, if it is under the action of two forces having the same line of action, same magnitude, and opposite direction, then this body is said to be at equilibrium. Also, forces are classified into two types: contact forces and forces acting from a distance. Contact forces are muscular force, normal reaction force, friction force, tension force, while the forces acting from a distance are the magnetic force, electric force, and the weight force. But today we are going to talk about the force exerted by an elastic spring, which is called the tension force. Each force is characterized by its point of application, line of action, direction, and magnitude. So, let us list the characteristics of the tension force. Point of application is the point of contact between the object and the spring. Line of action along the spring. Direction depends on the situation toward the interior or exterior, like that shown in these cases. Magnitude. What about the magnitude? In this video, we are going to learn how to determine the magnitude of the tension force. Hooke is the scientist who did an experiment to find the relation that helps to calculate the magnitude of tension force. But before starting to do Hooke's experiment, you have to recognize these definitions and rules. The length of the spring when it's free and loaded is represented by L0, that's the free length. While when loading this spring by a mass, this spring will elongate, and the length of this spring when loaded is represented by L, extended length. The elongation that takes place when the spring is stretched is represented by delta L or X, where in this case of stretching, delta L is equal to L minus L0. That's the difference between these two lengths. While in case of compression, the length of the spring when loaded will be smaller than when it's free. Then delta L, which is the difference between these two lengths, will be L0 minus L. So, delta L is equal to L minus L0 in case of elongation and L0 minus L in case of compression. Let us start with Hooke's experiment. Bring a spring hanged by a stand, ruler to find the length of the spring, and different masses. Then follow these steps. Measure the spring length when it is unloaded L0. Hang the first mass. Calculate the corresponding weight. Make use of state of equilibrium of the mass to deduce the magnitude of tension. The mass is at equilibrium under the action of two forces that are weight and tension, such that weight equal tension. Measure the spring length when it is loaded L. Measure the elongation delta L equal L minus L0. Let's start finding the relation between the tension and the elongation. This is the spring. Its free length is L0 equal 30 centimeter. Then let's fill this table. In the first figure, where this is the first figure, this is the first case, there's no mass here, so the mass is equal to 0 kilogram. Then to find the weight, referring to the formula of weight, that is mass times gravity, then the weight will be equal 0 multiplied by 10, then it's 0 Newton. To find the tension, it's from a case of equilibrium, so tension equal weight, so it is 0 Newton. To find the elongation is equal to delta L, L minus L0. And here there's no mass, the spring is not elongated, then it is equal to 0 centimeter. This is about the first figure when there's no mass. Now, in the second figure, let's put a mass. It's of 50 gram. To find its mass in kilogram, then you have to divide by 1000. Yani 50 gram divided by 1000, it's equal to 0.05 kilogram. To find the weight, you have to multiply this mass by 10 by the gravity. So mass times the gravity, then it is 0.5 Newton. To find the tension, we said that tension is equal to the weight because it's case of equilibrium, then it is also equal to 0.5 Newton. Now to find the elongation, that is L minus L0, we have to find the length, the elongated length, the extended length of the spring using the ruler. It's equal to 36 centimeter. Then delta L is equal to L minus L0, 36 minus 30 that we get it from the first figure. Then delta L is equal to 6 centimeter. Now let's add another mass. We can find now the weight, multiply it by 10, then it's 1 Newton. Tension is equal to 1 because it's equal to the weight. Elongation is equal to 12 centimeter. Also we add another mass. It is now 0.15 kilogram. We find the weight, tension, and the elongation. Now let's divide the values obtained by the tension by the values obtained by the elongation. Let's start with the first figure, 0 over 0. It's impossible, nothing. 0.5 Newton divided by 6 centimeter gives 0.08 Newton per centimeter. 1 divided by 12, it's also 0.08 Newton per centimeter. 1.5 divided by 18 centimeter, it's equal to 0.08 Newton per centimeter. What can you notice? Look at these values. Whatever you add masses, the values obtained by dividing the tension over the elongation is always constant. What does that mean? That means that the tension and the elongation are directly proportional. To find the tension from this obtained relation, it is equal to T multiply x by 0.05 8 Newton per centimeter, then it is T equals 0.08 x. So in general, that is the tension, is equal to K multiplied by X. K is the constant number. This constant number is called the stiffness constant of the spring multiplied by the elongation. Then this is Hooke's law. Hooke's law states that tension in a spring is directly proportional to the corresponding elongation. That is the formula T equal K multiplied by delta L. To find K from this formula, it is T over delta L. And to find delta L, it is T over K. T is the magnitude of the tension in the spring. Its SI unit is in Newton. K is the stiffness or spring constant of the spring. Its SI unit is in Newton per meter. From Newton per centimeter to Newton per meter, we have to multiply by 100. Delta L or X is the elongation or compression of the spring, where its SI unit is meter. From meter to centimeter, you have to multiply by 100. Now let's plot the curve of tension relative to the elongation. The shape of this curve is a straight line and passing through the origin. So the characteristic curve of tension as function of elongation is a straight line that passes through the origin. The slope of the straight line represents the stiffness of the spring K. Let's solve this application about Hooke's law. Don't forget this formula, T equal Kx. In this application, they are asking you to find the stiffness of an elastic spring. We said that the stiffness of an elastic spring is represented by K. So the aim of this exercise is to find the stiffness K. An experiment was done as shown in the figure where step 1, free elastic spring, where L0 is equal to 25 centimeter. Step 2, the spring is loaded by a solid body B of mass 200 gram. Then the compressed length of the spring is L equal 20 centimeter. Part 1, name the forces acting on body B. Of course, the forces acting on this body are the weight and tension. The second question is to find the weight of body B and then deduce the magnitude of the force exerted by the spring on the stable body. To find the weight of the body, let's look at the given. They gave you the mass of this body B. Then you can find the weight referring to the formula mass times gravity. You have to convert from gram to kilogram by dividing by 1000. Then it is weight equal mass times gravity, 0.2 kilogram multiplied by 10, it's 2 Newton. The second part of this question is to deduce the magnitude of the force exerted by the spring. The force exerted by the spring means that the tension force, we have to find the magnitude of the tension force on the stable body B. Stable body means that it is at equilibrium. So referring to the condition of equilibrium between the weight and tension, it gives weight is equal to minus T minus tension and vector relationship. And magnitude relationship gives that weight is equal to tension, that is equal to 2 Newton. Now we get the magnitude of the tension, it is 2 Newton. We still have to find X in order to find the stiffness K. Number 3, calculate the compression of the spring. The compression of the spring means X. In case of compression, X is equal to L0 minus L. Then it is equal to 25 centimeter minus 20 centimeter, that is 5 centimeter, divided by 100, it's 0.05 meter. Number 4, deduce the stiffness of the spring. To find the stiffness of the spring, we have to apply Hooke's law. We get T, it's 2 Newton from the condition of equilibrium between the tension and the weight, and we get the value of X, that is 0.05 meter. Then apply this formula, K is equal to T over X, Hooke's law. Substitute the values 2 over 0.05, then it is 40 Newton per meter. Application 2. The adjacent graph shows 3 curves, pink, green, and orange curve. Number 1, identify the curve that doesn't correspond to an elastic spring. We said that the characteristic curve of an elastic spring that obeys Hooke's law should be a straight line, where these 3 curves are straight lines, and also should pass through the origin. Look at these 2 curves. They are straight lines and passing through the origin, while the pink one doesn't pass through the origin. So the curve that doesn't correspond to an elastic spring is the pink curve, since the characteristic curve of an elastic spring that obeys Hooke's law should be a straight line that passes through the origin. Number 2, identify the curve that correspond to an elastic spring with higher stiffness. We said that the stiffness is the slope of the curve. Then first we have to make a comparison between the green and the orange curves, not the pink one. Then the curve with higher slope has greater stiffness, which is the green one.
Let's make a summary. We learned from this video how to find the magnitude of the tension force using Hooke's law. By applying this formula, T equal K multiplied by X, where T is the tension force, where it is expressed in Newton, K is the stiffness constant that is expressed in Newton per meter, and X is the elongation or compression that is expressed in meter. This formula is found using Hooke's experiment. Also, we studied the characteristic curve of elongation of a spring, where it is a straight line passing through the origin. This video is prepared by teacher Kawthar Noon, recorded by teacher Zainab Saifuddin, reviewed and supervised by teacher Saria Muqbal. Thanks for your attention.